The last item in section 1.1 is called level of measurement. And level of measurement kind of goes along with this concept of qualitative versus quantitative variables and data and so on. So definition. A variable is at the nominal level of measurement if the values of the variable name, label, or categorize. In addition, the naming scheme does not allow for the values of the variable to be arranged in a rank or specific order. A variable is at the ordinal level of measurement if it has the properties of the nominal level of measurement. However, the naming scheme allows for the values of the variable to be arranged in a ranked or specific order. And I'll talk about the interval and ratio in just a minute. So again, these are called levels of measurement. And basically, it's sort of a way to kind of break down even qualitative variables a little farther and quantitative variables a little farther. So nominal and ordinal levels of measurement are generally going to be dealing with qualitative variables, whereas interval and ratio levels of measurement, the last two that we haven't talked about, are generally going to be dealing with quantitative variables. So basically, with a nominal level of measurement, what that means is there's no quantitative aspect to this variable at all. There's no quantitative aspect at all. The best you can do is categorize or label individuals by a name. So again, something like male and female, when we're talking about gender, that would be a nominal level of measurement. The best you can do is categorize by that. Now, if we step up the sophistication just a little bit in the level of measurement, we move to ordinal. So now we would still be categorizing individuals, but we also have a quantitative aspect to it. So for example, if we talk about something like small, medium, large, extra large. Now there's no absolute meaning to what small means. There's no absolute meaning to what medium, large, and extra large means. Depending on the context and so on, small could be bigger in one scenario than in another scenario. Okay, so small just means small. So the best we could do is categorize individuals by small, medium, large, or extra large. But there's a quantitative aspect to that. So clearly, small is smaller than medium, medium smaller than large, large is smaller than extra large, but there's not an absolute meaning to any of those. So we're categorizing, but there is an order to it, but the order's loose. So those are qualitative variables. But again, a qualitative variable could either be just plain nominal or it could be ordinal. Ordinal means there's an order. Nominal just means you can name it. So other examples of that is any kind of a ranking scenario where the differences between the ranks don't have absolute meaning. So if we talk about even like a class rank, number 1 in a class, number 2 in a class, number 3 in a class, number 4 in a class, that's a ranking scheme. And the difference between person 1 and person 2, number 1 in the class and number 2 in the class, isn't necessarily the same as the difference between number 49 and number 50. There's a difference of 1 in the rank, but there's not an absolute meaning in what that difference of 1 means. So like a ranking scheme of class rank is an ordinal level of measurement. Other examples would be things like ratings scenario, like a 5-star restaurant versus a 4-star restaurant. Well, obviously a 5-star restaurant is, at least in the opinion of the critics or whatever, better than the 4-star restaurant. But what's the difference of 1 star mean? It's not an absolute meaning. So a ranking system like that, again, stars, would be an ordinal level of measurement. When we talk about order, incidentally, we're not talking about like alphabetical order. You could put anything in alphabetical order, but alphabetical order doesn't mean anything quantitatively, and so that doesn't count. So interval and ratio I want to talk about together as well. So a variable is at the interval level of measurement if it has the properties of the ordinal level of measurement, so there's an order to it, and the differences in the values of the variables have meaning. A value of 0 does not mean the absence of quantity. Arithmetic operations such as addition and subtraction can be performed on values of the variable. So the interval level of measurement is actually kind of a tricky one. With an interval level of measurement, we have a scenario where there's meaning within differences of the quantities, but there's not meaning in ratios of quantities. So in other words, like multiples, there's no meaning in multiples. Now the ratio level of measurement has the properties of the interval level of measurement, and the ratios of the values of the variables have meaning. Again, in other words, multiples have meanings. The value of 0 means the absence of the quantity. Arithmetic operations such as multiplication and division can be performed on values of the variable. So basically the deal is with the ratio level of measurement, you can multiply and divide and the results have meaning. But on the interval level of measurement, you can add and subtract and the results have meaning, but you can't multiply and divide. The multiplication and division doesn't have meaning. So again, that's the idea that it's absent of ratios, like multiples don't work with interval level of measurement. The most definitive way to be able to tell the difference between whether you have an interval level of measurement or a ratio level of measurement is to think about 0. Is there a 0 to the scenario that you're talking about? Like, for example, number of siblings. 0 is a legitimate response, and 0 would mean what? You have no siblings. If you have an interval level of measurement, there's either no 0 at all, or if there is a 0, 0 doesn't mean what 0 normally means. 0 normally means the absence of the quantity. There isn't any. And so at the interval level of measurement, 0 doesn't mean absence of the quantity. So, examples. There are very few examples of interval level of measurement. For example, if I ask you what time you woke up this morning. So if one of you said, I woke up at 6 o'clock, and another of you said, I woke up at 12 o'clock. Well, that's a 6-hour difference. You know, one person wakes up at 6 o'clock, another person wakes up at 12 o'clock. There's a 6-hour difference. There's meaning to that. But the fact that 12 is 2 times 6 doesn't mean anything in terms of what time you woke up. So there's meaning in the differences. The 12 o'clock person woke up 6 hours after the 6 o'clock person. There's meaning in the differences, but there's not meaning in the multiples. The fact that 6 times 2 equals 12 doesn't mean anything when we're talking about time when you wake up. So clock time is one example of an interval level of measurement. Remember what I said about meaningful 0. When we don't have a meaningful 0, that's generally going to be interval level of measurement. If you think about time you woke up, you think about the clock, there isn't a 0 on the clock, right? So there's no 0 in that scenario. But even if we were using military time, where it's like 0600 versus 1200 hours that you wake up, there is a 0, that's like midnight, but that's not like when time begins. So again, there's no meaningful 0 in terms of absence of time. Other examples of interval level of measurement is calendar years. What year were you born? So if one person's born in 2005 and another person's born in 2007, there's a 2-year difference. But again, multiples don't have meaning when we're talking about calendar years. And again, calendar years, if you think about that, there isn't a year 0, but even if there was a year 0, that doesn't mean absence of time. So calendar years are at the interval level of measurement. Other examples are temperature. So if you're measuring temperature, whether it's in Celsius or in Fahrenheit, those are at the interval level of measurement. And that's about all. So clock time, calendar years, and temperature are about the 3 examples that we can give for interval level of measurement, where again, there's meaning in differences, but not meaning in multiples. Pretty much every other quantitative variable is going to be at the ratio level of measurement. So like number of TVs. Well, if one person has 10 TVs and another person has 5 TVs, the person with 10 TVs has twice as many. That's meaningful. There is a meaningful zero. If an individual has 0 TVs, that means absence of TVs. They don't have any. And so that's the idea. So let's take a look at this example, which again is going to be using these levels of measurement. So determine the level of measurement of each variable. So again, our answers here are going to be nominal, ordinal, interval, or ratio. So gender. So there's no order, right? So the best you can do is categorize someone by gender. There's not a quantitative aspect of that. The number of absences during a course. Is there a meaningful zero? Could a person be absent 0 times? So that makes it ratio. If one person misses twice and another person misses 6 times, the person who misses 6 times has missed 3 times as many as the person who's missed twice. There's meaning in the ratio. There's meaning in the multiples. There is a meaningful zero. 0 means an absence of absences. So this is ratio. Temperature. I think I gave that earlier. That is interval. The only exception to temperature, and I probably should have been a little more clear on that problem, temperature measured in Celsius and Fahrenheit will be at the interval level of measurement. There is also a scientific measure for temperature called Kelvin. Kelvin is actually ratio level of measurement. So if there's any scientists here, if something is, say, 50 Kelvin versus 100 Kelvin, 100 Kelvin is literally twice as hot as 50 Kelvin. There is a meaningful zero. 0 Kelvin means absence of any heat. But otherwise, temperature, Fahrenheit and Celsius, is going to be interval. Letter grade in your last math course. So again, there's a ranking. What are the possibilities? A, B, C, D, F. Well, obviously an A is better than a B, but there's no absolute meaning between the difference of an A and a B. I mean, it could be that one person gets a B because they had an 89% and the person gets an A because there's a 90%, so that's a difference of 1%. Whereas it could be another person has 80% and a person with an A has a 99%. So there's no absolute meaning in the differences in those letter grades. Time you awoke this morning. There's so few of those interval examples that you kind of have to spoil a question like this on an example because there's so few examples of that. I've given you pretty much all of the incidences of when you're going to see interval. The time to drive to campus. Now, I do want to address the zero thing from a practical standpoint. Could someone drive to campus in like 0 minutes? Probably is not the case, right? You would have to live on campus if you were going to drive to campus in 0 minutes, so to speak. So 0 doesn't have to actually be possible. It just has to mean the absence of the quantity that you're talking about, right? So it's not possible for someone to drive to campus in 0 minutes. But if that was possible, 0 minutes would mean no time. They were able to get there in 0 time. So when we talk about things like weight, it's not possible for someone to weigh 0 pounds, but weight would still be a ratio level of measurement. Someone who weighs 100 pounds weighs twice as much as someone who weighs 50 pounds, for example. G, pain rating on a scale from 0 to 10, 0 meaning no pain, 10 meaning excruciating. So again, there's no absolute meaning between, say, a ranking of 2 to 3. There's no absolute meaning there, and so that's what makes it ordinal. And last but not least, color of your car. Then that completes section 1.1. So you should be able to handle the section 1.1 homework in MyLab.